I'm Nick Boros, space industry analyst and founder of S02E92 Consulting, and I listen to the Cold Star Project.
This show is for entertainment purposes only and is not what is termed professional advice. The Cold Star Project is proudly presented by the Operational Excellence Society. Cold Star Tech is a supporter of the OPEX Society, and Jason Kanigan is a member of its board of advisors. Talk with us at Cold Star Tech to find out what we can achieve together with your Lean Six Sigma or Operational Excellence programs. And check out opexsociety.org to learn more.
Hey, this is Jason Kanigan, the founder of Cold Star Technologies, the systems and processes installer for space and defense companies. If you're having trouble with bid capture, come to us. We can help you with innovative methods, finding out what your actual strategic competitive advantage is, all kinds of things that people don't really think about until we lead them through a process. Today's guest is Marco Cross. I've had the pleasure of working with him a little bit. He just finished getting his master's degree through Brown University under Dr. Rick Fleeter, who is our engineering advisor. Marco, full disclosure, is also our engineering and commercialization advisor here at Cold Star Technologies because he is not a kid. He has some really great experience leading design and engineering on products out there in the real world that have sold over 2 million units in 5 years, and that number is also increasing. And so he has some really great experience commercializing products. He has past roles at multinational design and engineering firms, leading innovative strategy in engineering and medical device and consumer tech products. He's also been, this is more relevant to us, chief engineer on multiple CubeSat and SmallSat programs. They just launched one a very short time ago, which we'll discuss a little bit. And he has commercial space launch experience. So Marco, welcome.
Okay, so you just launched a satellite of your very own. Actually, it's Brown's and University of Florence and something like that. Dr. Fleeter was kind enough to send me a news article about it over WhatsApp the other day that I will link to in the description. With the amusing name of SBUDNIC, play on Sputnik, obviously. And so I'd love to hear about your experience in doing this. It was through Brown University. You know, what happened with the team in creating this thing? What did you learn about putting together a satellite really fast?
Building the satellite incredibly quickly was very difficult. I think one of the main challenges that we came across was that the space industry is entirely reliant on existing flight precedent. And given the tight timeline that we had and the tight budget that we had to be able to do this, the other piece of the puzzle is that we did it for 10K. I mean, our built parts budget, not our R&D budget, but our built parts budget was 10K. 10K is not enough to build anything really, and certainly not enough to buy even like a reaction wheel for a stabilization system. So what that meant is that we had to substitute labor hours for money a lot of times, and we had to do a lot of workarounds. And even in the absence of, or even in the presence of a lot of money, we still would have had to do this just because timelines for delivery on space parts are insanely long. I mean, some of the initial parts that we had spec'd out before we kind of had a concrete budget in mind took 6 months to deliver. You can't do that. That's just not going to work for a year-long project. So we did a lot of inventing. And what that meant from a day-to-day perspective is that prototyping in analog materials became super, super, super important. Like we had to do things on the cheap, but then using 3D printed parts that we printed on consumer grade 3D printers became very, very critical. At one point we were testing a radio assembly using tinfoil that we had strung over basically a cardboard frame that was designed to replicate the shape of our satellite as we had designed it. All of these things became super critical. And I mean, I can show you here. I happen to have this sitting on my desk. There you go.
Yeah.
This is a sample panel from the satellite. And what you're looking at is potting compound and Kapton tape that are just layered over an aluminum panel. And that became our thermal control solution. We were able to calculate the aggregate emissivity of that panel. And by varying the width, or basically the ratio of Kapton area to potting compound area, we were able to control the overall thermal properties of the panel. This was because we didn't have money or time to be able to source a high-end aerospace coating with a 6-month lead time at for $5,000 per liter. That just wasn't in the cards. And this solution is, I think, the best example of something that we kind of figured out on the fly.
Wow. Okay. So how was it, like herding cats, or was everybody lining up pretty well when you told them, look, we need your creativity and we need to move fast here?
No, I mean, I think everybody was really down for the challenge. We were very open upfront with the project, in that, if people wanted to stay involved, they could. And if they didn't want to stay involved, then they could drop off and go do something else. But they just needed to be honest with us and let us know so that we could plan our project around it up front. And I mean, the retention rate on the project over the year and a half, we had, I don't know, I mean, we had no constraints over who was going to participate in the project. We just said, if you want in, you're in. And I think we interviewed, by interview, I mean, we onboarded something like 65 people. And at the end of it all, we ended up with a team of about 52. And I would say about 25 of those people were regular contributors, and the other 25 we could count on for like one-off projects here and there.
Is that normal for a satellite? Those numbers?
No, I mean, our team is super small. Yeah. So the fact that we were able to do something like this with even 50 people, even if everybody was working full time, that's insane. To be able to do this with 25, I think, again, is a testament to the power and intelligence of the team. I'm very proud of them for that.
Okay, excellent. So what was the mission of the satellite?
Yeah, so SBUDNIC, I don't know when you're going to post this, but today is May 19th. Am I blowing you up by saying that? No, cool. So today is May 19th. SBUDNIC is going to launch on May 25th on Transporter 5 out of Cape Canaveral. The overall mission of SBUDNIC is basically to prove out this idea of using commercial off-the-shelf parts, COTS parts, as NASA defines them, and doing this in a super, super fast way. That was kind of the overarching like meta mission. That's like the big idea up at the top. The technical side of things is a little bit more based on the delivery of parts as they developed over the course of the project. So our technical kind of end state evolved, our technical end goals evolved as we figured out what we were able to do in the time that we had. So at this point in time, being that the satellite is done, we integrated it 2 weeks ago. It's launching in 4 or 5 days from Cape Canaveral in Florida. The technical part is that we're taking pictures from space. We're beaming them down over ham radio. So if you have a ham radio license, you'll be able to tune in, just pick them up, no problem. They're all open source, open encoding, whatever. We're publishing all this stuff on our website. And then the satellite also has a drag device that shoots out the back, which will deorbit the satellite in about 6.5 years, depending on atmospheric density, as opposed to 22 or 24 if there was no drag device. So a similar mass, similar volume, similar size, without a drag device would have taken about 22, 25 years to deorbit. And again, it's hard to predict these things because it's largely dependent on the solar activity, which then affects atmospheric density, and solar activity is not like, it's not like the weather next week where you can kind of get a good idea based on the Doppler. There's no Doppler for solar flares.
They just kind of happen.
They just kind of happen.
Yeah. You did a lecture for Brown about space engineering and introduction to space engineering that I'll link to in the video description. I learned a lot from it. I messaged you excitedly Friday evening. I was looking at it. When you posted it, I was like, oh my gosh, it was a Northrop Grumman heat dissipating material that was glowing red hot, and you could touch it. It dissipated heat so fast. It just, getting an idea of how tough this is, right? Engineering these things, and hoping that they work, right? Let's look at the hardware prototyping process. You did some for this project. You have commercialized a few products before, and from your talk in that lecture, I know something about you, Marco. I know that you have a different approach from Rick Fleeter and myself, for example. I tend to be on the Rick side of let's do some math and figure this out, right? And some theory. And you're down there with a piece of foam cutting the shape out, which I respect tremendously because I can't do that, right? I'd probably cut my finger if I tried to do something like that. So I need you, for that kind of thing, for this fast prototyping of that. Talk to us a little bit about that design process and how you go about doing it in the space environment where you make something, you test it as best as you can, and then you're going to put it up there and it's either going to pass or fail, basically, right? What kind of considerations are going through your mind as you're developing these things, and also depending on a team of a whole bunch of other people who don't necessarily use the same approach as you do?
Yeah. So my background is in industrial design. That was kind of what I started off with as a young undergrad. And I did industrial design straight out of undergrad for a couple of years. That's where my commercialization track record started, but it was not at all in the context of space. It was in consumer electronics and some healthcare devices, some medical devices. I carry that approach that I learned in industrial design into space engineering. And what that broadly entails is doing rapid, iterative prototyping using the cheapest, fastest to manipulate materials possible to figure out an answer to a question. And I won't say that it's capable of supplanting math in general, like it's not. I do just as much math as anybody. I rely on equations too. There's a lot of things with it are not prototypable. However, I would say that in my experience, the space industry and the defense industry at large are really invested in this notion that there's absolute empirical truth in math and solely math. And there's a hard divide between engineers who design things and then technicians who build them. I think that divide is frankly bullshit. And I think it's detrimental, largely detrimental to the validity and applicability of a lot of the projects that end up getting pushed out into space. And it's part of the reason why the space industry at large is still super dependent on flight hardware that's been flown before, because nobody is willing to actually kind of like go out and prototype and try something new. And there are companies that are doing that. I don't want to knock them, I'm not saying that nobody's doing that. I'm just saying that in general, there's a reason why SLS is using the same engines, SLS being the newest, greatest thing that the US government can put out there. SLS is using the same engines that were used on the space shuttle. And yeah, so as far as prototyping in a more practical sense, I think the increased access to space that we now benefit from is fundamentally changing the approach that people are able to take when they're building stuff. So yes, I really want this satellite to work. I mean, I've worked on it for the last year and a half, and it's countless labor hours that have gone into it. But at the same time, I know that I will likely now have many more opportunities to put up a satellite if I do it in a year and a half using rapidly iterative materials that are commonly available versus if I spend 25 years building the biggest, baddest satellite that could possibly be built. Like that's not a realistic look at the way things are anymore. I mean, the cost per kilogram of carriage to LEO is now, I don't know what, I mean, the estimates vary, but let's say conservatively it's $6,000 per kilo. That's only going to come down. And that's a couple orders of magnitude less than it was even 20 years ago. So, I mean, 20 years ago, we're talking about the inception of things like the James Webb, which just got launched. What's going to be 20 years from now? The development prototype and engineering process for space is going to be fundamentally altered by the access with which, or the level of access that we now have to put things up in orbit.
Excellent. Yeah, Marco, I get very wary out in the commercial field about having a one right way to do things, right? And being too dependent on the philosophy that we see in space that comes under that flight heritage approach, right? It has to have been done before or else it's too scary risk on.
Yeah,
Which is, yeah,
to
go ahead.
continue on that point. Yeah. So I think the other thing too is that I was talking to a professor at Brown, and he is one of the PIs, principal investigators, on a couple of one of the lander missions and an upcoming asteroid impact mission. And I was talking to him about why there's not more distributed, cheaper, lower cost systems on Mars, on the moon, on things like that. Like, why are we sending up $50 million rovers when we could be sending up $5,000 RC cars and sending up 100 of them? And he looked at me and he kind of was like, he started laughing and he was like, well, it's people like you, it's your fault. And I totally was taken aback by this answer.
What?
Yeah. And he's right. It is my fault. The idea being that people like me are only interested in doing the newest, greatest, sexiest thing. And so when there's an opportunity to do an iterative process of like, okay, we are going to, for example, put 150 small little RC cars on the moon and have them map the terrain of the moon or something like that. Who wants to do that? Nobody wants to spend all of their time developing something that is ultimately just going to be replicated again and again and again, because it's not new, it's not fun. Now, I don't necessarily agree with that opinion, because I think there are a lot of people who would be really excited to build a company around building a lot of little lunar rovers or whatever. However, he's right to some extent. But I think by focusing on lower cost parts that are commonly available, I mean, SBUDNIC uses an Arduino board as power or to do the compute on board. We can take risks in other ways. So instead of taking big, sexy mission risks where we're like tracking the development of phosgene gas in some, or phosphine, sorry, in some faraway galaxy, we're taking development risks and iterating really rapidly by building actual hardware that's going to fly in no time at all. So the risk calculus and like the sexiness changes from one of like overall mission, like, oh, I'm working on the James Webb huge, big, beautiful thing, to like, oh, I'm building something cheaper, faster, smaller, lighter weight, than more nimble than it has been built before. It's a little bit of a different way of thinking about things.
Yeah, Jason Kanigan doesn't need to do cool stuff. I've often joked I'd be happy being the third-party auto parts manufacturer for the space industry. You know, get your cool car skirts and your headlights and stuff like that for me. And a modular, cheap, I love it. Right, all over the place. Let's make some money and have an impact. Right, people are using this stuff. I don't need to make the coolest thing. You know, having talked with Rick Fleeter a lot over the last couple of years, his approach, he'll get exasperated with mission profiles of satellites where they're trying to hang on every kind of Christmas tree ornament you can think of. And each one of those gives yet another opportunity for partial mission failure, right? If that breaks. How did you, with the SBUDNIC mission, narrow down to, okay, this is what we're going to do, you know, and keep it clean?
Yeah, so we started off with, I like to think of development in general as kind of a funnel. You start with a lot of really big ideas. You kind of narrow things down. You start to kind of refine, define, and eventually you get out to a tiny little point in the middle where only the purest best drips out the bottom, you know, the stuff you actually use. So we started off with a gigantic wish list of things that we wanted to do in space, and we quickly validated that wish list against the technical constraints and budgetary constraints and time constraints that we had. Originally, this project was in large part funded by the National Research Institute of Italy. And the original goal of our counterparty at CNR was to develop kind of a GPS system for satellites in space. And that eventually morphed into something where we're literally just proving out small chunk, you know, we're only taking a small part of that project, but a fundamental part, which is, can we build a satellite really cheaply, really quickly, using commercial off-the-shelf parts exclusively or nearly exclusively? And ultimately, this is going to be kind of something that iterates into, with future launches, future development, into the system that CNR is envisioning. And it may take some time, but at least it'll be well validated in other ways, instead of thinking about like, we're gonna spend all this engineering dollars up front on making sure this works before we launch it. We're gonna spend less engineering dollars on launching a lot of different experiments and then moving forward with the ones that work. An evolution, if you will. So our process, to answer your question more directly, was evolutionary. It was a function of what can we do, how can we get this done quickly, and what are our resources available to us at this point in time.
Okay, excellent. You have told me prototyping starts with good learning up front, followed by you've seen a lot of people fail because they get down into the process, but they didn't get that upfront validation that they needed. Can you think of an example or two? What I'd like to do is have, especially young people, young engineers listening to this who are students now, are going to get out there into the world. Maybe they'll remember this one point. I certainly function this way, right? Where I walk into a situation that's new to me and I'll remember, wait, that guy Marco said to watch out for this.
Yeah. So it's a difficult thing. And I'll speak from the perspective of industrial design, because I think the industrial design industry does this well. Is in industrial design, there's this subfield called design strategy, and it's sometimes baked into like innovation strategy or whatever, which is a sales process. But design strategy is ultimately a discovery state where you're not actually doing any building or thinking about how things work, but instead you're thinking about how things could affect people or affect systems. And that starts with going in, doing user interviews, visiting with stakeholders, understanding the constraints. It's a total blitzkrieg of information. It's everything that could possibly affect the system or the object that you're designing needs to be considered in a lump before you go and say, well, I'm going to do this thing, because ultimately the thing that you're designing, the object that you make, is a function of the constraints that you're working within, and it's not the other way around. The systems that go the other way around, or objects, whatever, that go the other way around fail, always fail in one way or another. They may end up in the context of space, they may end up getting up into orbit, and they may work in orbit or whatever, but the data that you're getting is not as complete as it could be. It's not as useful as it could be to all of the people that are involved. So if I were launching a satellite, let's just do like a hypothetical exercise here. So if I were launching a satellite that was supposed to do Earth imaging, I would, instead of, and this is like kind of indicative of the type of contract that's available. Government issues these all the time. It's like, we need an Earth imaging satellite. Okay, why? Do you really need an Earth imaging satellite, or do you want to take pictures of crops from space, or do you want to see troop movements on the ground, or do you want to understand climate change? Because what you're thinking of, what the typical RFPs always come with a presumption that an RFP being just kind of like a general stand-in for people asking for things. People ask for things and they immediately make an assumption about how the thing needs to be accomplished. It's not about the thing that being accomplished. It's about understanding the data or understanding the underlying need that ultimately caused them to ask this question in the first place. So if I were, again, hypothetically thinking about how to build a system that tracks global climate change and sea level rise, I wouldn't start with a satellite. I would instead say, okay, well, what are the factors that are important for me to measure? Okay, well, I should probably measure dune erosion. That's probably important. In what area am I going to measure dune erosion? Well, I want to measure just on the East Coast of the United States. Okay, cool. How often am I going to measure dune erosion? I'll probably measure it once every day. I just want, an average once every day. That'll give me a good overall data point. That's enough data. Okay, so all of these things could be done by measuring from a satellite, taking a picture from a satellite, but they could also just be done by putting a stick in the ground that measures how high water is coming up the stick, like that like a networked ruler, basically. That doesn't necessarily have to be done in space. And there are also a kabillion other ways to answer that question too. So the design industry, like I said before, is really good at divorcing itself from the end state and saying, okay, well, here's the problem, and speccing the problem really well up front, understanding the fundamental underlying issue. I think the space industry in general would be, counterintuitively, perhaps less funded if people actually started with the notion of what is the real problem, because space is terrifically hard. Why would anyone ever want to launch a satellite? It's ridiculous.
When you could put a stick in the ground, right?
Yeah, or like even easier. Why not just send a group of people up and down the coast, pay them for a year of your time? That's going to be a fraction of the cost of a satellite system. You know, just have somebody go out and measure these kinds of things. But there are answers that really need space, and those are exciting questions when they do come up.
Okay, very cool. Thank you. Different perspective. Yes, we should not build a constellation just because somebody asked for it. Let's think about it.
Yeah.
Let's talk about selling space, though, and your ideas about the public and their point of view, or maybe even like up on the Hill, the congressional assistants in that have their opinions, and those affect budgets and that. How alive do you think the dream of space exploration is?
I think the greatest and worst thing that's happened to space in the last 15 years has been Elon Musk. And it's the greatest thing because he is, above all else, a marketer and an exceptional communicator. He's managed to capture the soul of a nation, the United States, by just doing something remarkably hard and being very open about how he's doing it. And then setting an incredible goal of like, oh, we're going to live on Mars. Well, holy shit, that's insane. We're going to live on Mars. What? I mean, people can't even conceive of that. And he does enough stuff that he does enough that it's conceivable that his goal is realistic.
Credible.
Yeah, it's credible. I think the worst thing that he's done is that he's defined space as only a couple things, which is we're going to move to Mars, we're going to make it multiplanetary. And there's no counterpoint to his point. So there's no, he's worth $250 billion with no exaggeration. There's no other $250 trillionaire out there in the world who's also kind of thinking big like that, who's saying, okay, well, instead of colonizing Mars, we're going to instead send a generation ship out into space and see where it goes. We're going to try and send something to Alpha Centauri, only a couple light years away. But, you could conceivably get there with a suitably fast ship in a couple hundred years. I mean, that's not unreasonable to be able to do that kind of thing. It'd be crazy, but so is going to Mars. The point being of all of this is that it's important to set these lofty goals and then work towards them and demonstrate public progress, because it gets people to fall in love. And what I often see with congressional oversight in the United States is that Congress people are responsible for going back to their voters at the end of the day and saying, well, we made a responsible decision with your dollars. And then counterpoint to that, we also did something that is super sexy. So on balance, if you look at adjusted for inflation numbers, NASA has actually been underfunded. It's about $4 billion underfunded versus where it was at the height of the space industry back in the 60s. That's sort of sad. And I think it's incumbent upon us as space fluent people to stand up and say, well, space is really important, and we need to tell human stories about how and why we're going. And again, that's, I think, what Elon is doing. When he's talking about something being really hard, it's because it is. There's not really a whole lot of other space companies out there that are being so public and open about how they're getting up to space and what's being done to make their dream a reality. You know, you look at like Blue Origin, I think is the closest in terms of, you know, billionaire super founder versus billionaire super founder. Blue Origin is just sent, they're getting closer. You know, they sent William Shatner up to space, and they have some stories, and people come back and they write stories, and they experience the psychological phenomenon of the overview effect when they're up there. So they feel like the Earth is just a small blue ball and it's so fragile, and they come back down and they talk about it. Like that's important. But there's nobody that's really kind of like aspiring for greatness and, you know, writing The Hobbit, if you will. You know, like there's nobody like writing the epic as it's happening other than SpaceX at this point. And for a while, that was NASA. Back in the 60s, we were sending people to the moon. And then NASA stopped doing that. And I think that's a shame. You know, that's a real shame. We should be back on cheering up or cheerleading space as a human endeavor, and inspiring those who come next to do something that's crazy, because that's the only way things ever get done, is if people get inspired to actually participate. Otherwise, we're just stuck in the same cycle that we've been in for the last 40 years, where we've built increasingly complex systems with increasingly limited functionality, to the point where them are tired, to the point where for a brief period of time, the American space industry was reliant on Soyuz rockets to get all their astronauts up to the ISS. What a shame.
Right.
That's terrible.
Yeah, I agree. Okay, so we get this idea that selling of space is something we should be conscious about and be trying to fuel those fires. Stories are really important. What can we do about it as individuals? Can we make sure that we get out there and broadcast like what we're doing here on this show? I feel like that's it's a spit in the ocean, right? It's nowhere near enough.
Yeah, I mean,
are there any answers?
It's true. It's a small piece, but it's helpful. You know, hopefully this conversation or some other conversation on your podcast, for example, get somebody thinking about something, and then they in turn spur something for somebody else down the line. I think the number one thing that people can do right now is start making stuff for space. And I know that's still a very high bar. It's a lofty goal, but I mean, my team and I have proven out over the last year really, that it's possible. You can do it affordably. Citizen science is real, and it's something that we can all achieve and aspire to do. I hope that NASA, in its funding goals for the next 10 years or so, is a little bit more open to funding citizen science initiatives, so that people who are unaffiliated with major universities, big companies, major governments are also able to seek the same opportunities that those major institutions have been able to seek in terms of launch space or federal dollars or things like that. And having looked through a couple of those requisitions over the last couple of weeks for an unrelated reason, I see NASA is starting to lean that way. They're being a little bit more specific about funding citizen science. That's amazing. That's a really big deal. And if you have the gumption to go out and try and do something for space, you should just go do it. Try to do something interesting and learn from everything that you can that's already been done. I know, Jason, you've talked about this with me, where there's not really anybody in the space industry who's upset about sharing all of their information. You know, like everybody's super open and friendly and kind. It's a small community, and it's a small community looking to grow within the limits of national security laws. But, you know, like people are pretty excited when you say, hey, I want to build a satellite. Well, great. What can I do to help? I mean, that's great. That's exciting. People should do that more. And I hope that students who are not in universities are also able to get involved with space in a way that's meaningful. I mean, $4,000 for a kilo of space to LEO, for a kilo of mass to LEO, is no small chunk of change, but that's enough or low enough that some of the larger or better funded school districts in this country, in America, and start to put up their own little experiments. And that's just a satellite, I mean, what's to stop a high schooler and a high school team from building a satellite? I don't know, try it, see what happens. There's no risk. In the meantime, you learn something. If the satellite blows up in orbit, like, I mean, that sucks, but at least you tried. That's really important.
How about, because I have the mad scientist inventor types who aren't affiliated with universities come to me, once a week, basically. And I don't know where to point them sometimes, right? I say find a university to go partner up with usually. How do these guys get onto launch vehicles and that? Just, I guess, approach NASA and try and find a way in and get directed to the right office and see what happens?
Yeah, unfortunately, it's still not that easy. I wish it really was. I think the answer there is to come with something that's, and this is true of any type of business development or opportunity search in general, is to come with something valuable. So if you're an inventor out there and you have a great idea for a space system, then go build it, or at least start prototyping it, and then try and approach NASA with that information, as opposed to, I have a great idea. Well, I'm sure, everybody's got great ideas. Ideas are cheap. It's they're free. In fact, the work and the actual object, the proof is in the pudding. And if you can bring some of that pudding to a conversation, that helps. So those madcap inventors you have, I would love to meet them. In general, I love people like that. But I think the number one thing to do is to start, do whatever you can within your means, and then start showing it to people and say, this is what I've been working on, as opposed to saying, this is what I want to do.
Yeah, there's more confidence, right? If we could chart that. Probably
yeah, and it helps sell the story too. I mean, even if it's a wild idea, if you've got a prototype that takes you 0.25% of the way down the path, that's still further. That's a million times. That's an infinity amount of times further than 0 steps taken down the path. It's important to start down the path.
And that's where most people stay, is in the 0. The dreaming spot. Let's finish up with a little discussion about the future of space engineering as Marco sees it. What factors do you see that are going to change, improve? Where should people be looking?
Yeah, so I really think that commercial off-the-shelf parts, COTS, whatever, consumer grade stuff, is going to be a lot more prevalent in space as launch opportunities become more frequent, cost per kilo to orbit goes down. And frankly, because consumer manufacturing is so good, there's no reason to buy a $45,000 low resolution camera array when you could just as easily wrap a $100, $150 point and shoot in like thermal blankets, keep it warm enough so it doesn't freeze, and then just send it up to space. There's, of course, a lot of technical nuance that I'm leaving out there, but I see that as being a major driver of the lowering of cost, lowering the barrier of entry to space. And I hope that as teams build more and more lower cost satellites, the kind of like flight heritage of these parts grows. So while I'm frustrated by flight heritage reliance in space grade parts, flight heritage does and is compelling. Past performance dictates future performance. So if somebody takes a risk and throws up a satellite that uses a camera or a radio that they pulled out of a walkie-talkie, that's incredible. Like, that's proof that idea works. I also think that we can safely rely on this idea that small satellites, CubeSats, are going to take over large satellites to a massive degree. There's no reason why we need to keep putting big, expensive, massy systems up in space when we can do effectively the same thing, largely, with small satellites. And I mean, you see that with SpaceX, for example, and a lot of the other internet constellation companies are putting up what is now considered like a normal size satellite, but even 30 years ago would have been large geostationary satellites. The Starlink clusters are built out of satellites that weigh, I want to say it's like 60, 70 kilos per satellite, something like that. Don't quote me on that, but they're smaller. They're much smaller. That's really exciting.
Yeah.
I've been continuously referring to this person named Rick Fleeter, and I think Rick's been on your podcast a couple of times, but Rick is a friend of mine and a professor at Brown University. And he's a big proponent of low cost, small space. And that's kind of where I became or he taught me to become a zealot, I should say, in that direction. But he has a lot of really interesting ideas about building distributed antennas using, for example, the cell phones in our pockets. We are all trying to put up antennas in space that are super powerful and capable of receiving even the most fractionally minute little piece of the puzzle of some cosmic blast coming from afar. Why not just use a million really low cost antennas that everybody's already got and use some really clever machine learning filtering, some algorithmic filtering to weed out what we actually want to hear and what's effectively noise. That's pretty amazing. So I think space exploration in that sense is even beyond small sats is going to be a lot more about what can we do with what we've already got. Like I remember when I was small, I was part of this group called Odyssey of the Mind, Destination Imagination. And it was basically like an after school club where my friends and I would go hang out at one of our parents' houses, and we'd build stuff together to a big problem that was posed at the beginning of the year. And this guy's house that we always went to, his dad worked from home, was one of the original Zoomers. And he, whenever he wasn't working, set his computers up to run the SETI processing algorithm. SETI, I don't think exists anymore, but do you know what SETI is?
Search for extraterrestrial life. Yeah. Big dishes. Yeah. The big dishes.
Right. Yeah. So they were pulling in data from big dishes, but all of the computing was done over the internet. It was distributed computing. That's pretty cool. Like why not, if everybody's got an antenna at home, why not just use that antenna and local processing? I think that's the distributed nature of space exploration in this context is going to mean that we're going to get a lot more widely distributed systems that allow us to process data in a way that we never really thought of before, using technologies that are already in our pockets. That's going to be pretty insane. Yeah, I hope that comes about. I think the other piece is that we're probably going to see a lot more constellations up there that are doing, in the immediate short term, we're going to see a lot more constellations up there that have single use purposes. So if a constellation costs, I don't know, let's say you can build a satellite for 10K and you can throw it up there for another 50K. So you've got basically 60K per satellite. You can throw up a constellation with a lot of satellites in it for $1 million and get whatever project you want done and out of the way. And then hopefully you're responsible enough to deorbit that constellation, bring it back down to Earth in a responsible way so it's not creating just more junk up in Leo. But that's going to be pretty cool. Increase in actual number of constellations and the overall use of those constellations is going to be term limited. That's going to be pretty exciting to see. A lot more opportunity for space innovation in that way. For designing hyper-specific instrumentation that really only needs to live for 6 months. What are we missing right now by launching big, like Mars rovers that are loaded down, as you said before, every ornament off the Christmas tree so that they capture every little bit of data. You know, that's cool, but nothing like that ever does any one thing well. You know, Alton Brown from Food Network, you know, he hates monotaskers in the kitchen. Everything has to have multiple purposes. One tool has to have multiple uses if it's going to exist. I'm the opposite way around on this. I think our space tools need to become really, really hyper focused, do one thing really well, and then destroy themselves. And that's like, so long as it's being done responsibly and orbiting stuff, we're using as few launches as possible, so we're not just burning rocket fuel for no reason. You know, we're doing things like that. Like, that could be really powerful.
Yeah, especially if you hook it up to a Space Forge or a company that recycles these things.
Yep.
Yeah, I cannot wait until we get a critical mass of stuff, of building blocks in orbit, and you know, are able to just have a cycle going on up there, and then move some things back and forth, and get a bit of an economy going, and then, you know, I think there's going to be explosive growth after that. Let's finish up with you've got a note here about the data transfer time to Mars, right? If we're going to go to Mars, it takes, with the speed of light, you know, a while, right? Minutes for communication to happen, and that's going to be weird. It's gonna almost be back to telegraph times, right? Send a message, it takes a while to get there. They got to decode it, got to wait, decide what you're going to do about it, then send a message back, right? How are we going to overcome that?
Yeah. So let's scope the problem a little bit right now. So if you're at your closest point, if Mars is at its closest point to Earth in its orbit, it's about 8 or 9 minutes transmission time to Mars. That's at speed of light. You know, it takes a while. That's not acceptable for real-time communication, especially with, you know, the fact that, like, you and I are sitting thousands of miles apart and having this conversation with no lag whatsoever. We're doing it great. You know, this is what we're used to.
Yeah.
I think a lot of the entrepreneurs who are invested in this idea of going to Mars think of this time gap as actually kind of a beneficial thing, because it allows Mars, or it would necessitate that Mars would develop its own currency, its own way of communicating. There'd have to be its own internet, like whatever, you know, there's that natural divide. It's kind of like back when we all got around the planet on sailed ships. You know, it took 3 weeks to go from England to America, and there was a non-zero chance that you're going to die on the way there. So it kind of limited the amount of transfer between all of these different points. I think that's not great for the future of humanity. I think it's important that if we're really going to spread and grow together as a species, we need to do so in a way that's in real time and empathetic and reactive to our human nature, which is to basically connect with people as often as we possibly can. So how do you get around this problem? It's really basic physics. Now, I'm not a quantum scientist by any means whatsoever, and this is just a absolutely crazy pie in the sky, wild idea. But it's been researched a couple times over by basically entangling quantum bits. You can teleport information across distances without any time delay. That's pretty cool. So now, like, China has launched a couple satellites exhibiting this exact behavior already. They were able to transmit over about 890 miles from a satellite up in space down to the ground. And then the United States has done similar things. ESA has also done similar things. Like, this is a really, really, really nascent technology. And it's going to be a long, long, long time before it's at a state where it can be done reliably and cheaply. That being said, it's probably going to be a long time before we get to Mars too. So maybe the two will coincide, you know, and the national security ramifications, for example, of real-time communication over infinite distance. That would be that would change everything about the way we live. That would be earth shattering. I mean, Mars shattering, put it that way. It'd be crazy.
Galaxy shattering. Yeah, because I've thought about that problem for a long time, right? With politics and that, with solar systems that are at some distance from each other. A revolution could take place over here and you wouldn't even hear about it at the other place for a very long time. And then what do you do about it, right? It's not like Star Wars where the Star Destroyers can just show up now and deal with it, right? Or you know, in the next day or so and deal with it.
Yeah, I mean, the idea of a generation ship, for example, becomes a lot more palatable if you can still communicate with your loved ones back at home or the people back at home. You know, I for the life, I would never, ever want to be on one of those ships. Like never. Yeah. That's not me. Yeah. But I know that there are some people out there who would probably be down for the adventure, whatever. But the reality is that those families are going to have to live like incredibly constrained lives on this ship that they will never leave for their entire life. And there's a strong chance that they'll die. That's not great. That's pretty shit. So if the odds can be made a little bit better for them, and then they can also still have some communication back to Earth to some degree, or back to a population center, whether it be on Mars or Earth or wherever, that is, you know, that's a lot easier to maintain culture, to build that culture. That's the piece of the puzzle that I think space is not yet unlocked. To go back to your earlier question, the people that are doing space communication really well and are inspiring the future are building culture around space. They're building lifestyles and they're getting people involved in making life decisions around space. We can do that with instantaneous communication across vast distance. Now, yeah, like this is super sci-fi stuff, but yeah.
It's cool hard science fiction, though. I mean, I knew about quantum logic gates 20 years ago, right? They were magazines with pictures showing these shaky little things, look like an X-ray. And yeah, we've had that much time to continue to look at these things. So I definitely want to have you back on, Marco, to talk about things like energy storage and whatnot.
I'm in.
Yeah, but I think it's a great time to end here. For now, we've been talking for 45, 50 minutes, something like that. And I don't want to strain our listeners too much, but I hope their appetite has been whetted to hear more from Marco Cross, who has this real world experience, right? Being an executive, being an industrial designer, coming up with commercialization plans for products and services and that kind of thing, and bringing that into the space industry and coming back and getting your master's degree through Brown. And joining us at Cold Star, among many other things. So super excited, and I appreciate you doing this, Marco.
Thank you for having me, Jason. It's always a pleasure to talk to you, even when we're not on a podcast.
All right. Thanks.
Hey, I hope you enjoyed that as much as I did. I really like Marco's way of thinking. It's a little different from my own, as I pointed out, and so there's always something to learn from getting a different perspective. So if you're interested in capturing more bids and you want to look at innovative ways of doing that, go to the Cold Star Tech website and check out the Innovation Capture page. It's right there, accessible from the homepage, and learn a little bit about what we're able to offer you. And if you're a founder or a president or a CEO or a vice president of sales in charge of driving revenue for a space or defense firm, I think that might be something you want to check out. Thanks for joining us, and I look forward to talking with you again soon.